Okay, thank you for the introduction. Yeah, I'll keep this real quick. Greetings from the suburbs of Washington, D.C. in the United States. This talk will be a little bit different from the other awesome presentations you've already seen here, mainly because I'm an experimentalist. I am not a computational fluid dynamicist or a computational scientist. And additionally, I am no expert in olfaction. That's not what I do. What I focus on really is understanding how to detect drugs and explosives. However, I don't have to tell everyone in this room here that trying to detect drugs and explosives requires sensing. It requires sampling. It requires sniffing. And so the work that you're going to see here is really focused on the dog's nose and what we learned by kind of visualizing what's happening when the dog is actively sniffing. So with that, thanks again for the invitation, and I'll go ahead and roll the video. Okay, I think we're recording. Hi, everyone. My name is Matt Staymates. I am from the National Institute of Standards and Technology, also known as NIST. We're in the United States. And I'm going to spend the next 13 minutes-ish talking to you about some work we've been involved in many years ago on trying to understand what the dog is doing externally, how it's interacting with its environment, and what that means, what are the implications for improving our ability to detect various vapors and gases. So quick background, I don't think I have to tell an audience like this that canines are considered to be one of the gold standards in trace chemical sampling. The things that dogs can do, the list seems to be growing almost, I don't know, monthly, right? And you can see the list here on the left over here. Amazing at finding people. Of course, law enforcement uses it for narcotics and explosives detection. This is something that I've spent most of my career on, working in drug detection and explosive detection. But you can see the list goes on and on. There's even, I learned about this recently, where there are specially trained dogs with someone who suffers from epilepsy. The dog can sense the onset of a seizure, and the dog knows how to break the fall of its owner, and then kind of lays on top of the owner as they might be kind of shaking, having a seizure, so that it doesn't hurt anybody else or hurt itself. It's really amazing what the dogs can do. And there was some work done here at Auburn University many years ago that, these are hard measurements to make because these are biological creatures, but they're estimating down in the order of parts per billion where they can detect in this case, these are explosive materials. So some previous work, wait, I don't want to start this video yet, sorry. Okay, so some previous work that was done in my alma mater at Penn State University many, many years ago. This was done by a buddy of mine named Brent Craven. I was getting his PhD at the time as my roommate. And his work was focused on the internal fluid dynamics of canine olfaction. I think similar to some of the folks in this room right now might be, maybe not canines, but the internal fluid dynamics using computational fluid dynamics of human airways and things like that. So similar idea. We were able to get our hands on a cadaver of a real female Labrador retriever, high-resolution MRI scans, and maybe CT scans, I don't recall. And then was able to reconstruct a three-dimensional model of the internal scroll work of the olfactory region, and then do all kinds of cool simulations on what's going on. So we learned a ton from this. The other thing we did, for the model itself, we had to input flow rates and velocities. So we built this special muzzle system, made measurements on all kinds of different breeds of dogs. And here's what's really interesting. We found that regardless of the breed of dog, so think little tiny Shih Tzu all the way up to a massive Great Dane, they all seem to sniff, not breathe or pant, but sniff at this fundamental frequency of 5 hertz. Actually, it's around 4.7 hertz. And there's some interesting biological reasons for that I don't have time to get into now. But it's a sinusoidal pattern, which you can see here. So fast forward, I'm working at NIST, and we're trying to figure out how to improve our ability to detect explosives and drugs. So what if we looked at the dog's nose? We're going to use a special imaging system called Schlieren that will allow us to look at how things are moving in air. So we tried to get a real dog, would not cooperate very long, and so we 3D printed this anatomically correct model of a dog's nose. You can see it down here in the bottom left. It's printing there. We have more sophisticated printers than this now. Here's what it looks like. So with Schlieren imaging, if you look at this video here, this is the warm air that's being moved around by someone's hand. Okay, the hand is usually warmer than the environment that we're in. With a Schlieren optical system, by the way, this system is a mirror, so this is a big 18-inch mirror, where it allows us to see refractive index gradients. But refractive index in air is tied to temperature and density. So in a way, I could say we're visualizing temperature gradients in air. So we did a lot of work with Schlieren early on in the pandemic, because you could imagine how this could be useful for looking at how gross humans can be with and without a mask. So we did all these embarrassing videos of me breathing with and without a mask, because you could see the warm air emerging from the human body as we exhale with this. So if you're interested in more of this, just, I don't know, Google Staymates, NIST, mask or something, and you'll find lots of embarrassing videos of me talking about this kind of stuff. Okay, so that's what we've done in the past. And now moving forward, I'm going to show you some results here. So here we go. We built a system that makes our artificial dog's nose sniff like a real dog. In fact, when we first built this thing, I kind of got a little out of control with flow visualizations. Wanted to verify that, in fact, the jets emerging from the nose of the dog are, in fact, turbulent. And they are. The Reynolds number suggests that, and we can actually visualize it here. So this is what it would look like if your dog took a drag on a cigarette or something. All right, here we go. So this here, and this is going to be a video. This can is there's acetone in this can. It's a little bit of nail polish remover. You can see acetone really well in a Schlieren system. And here we go. We're going to watch what happens when the dog is sniffing at 5 hertz. So let that play for a sec. So I love this. I love talking about this kind of stuff. Here's what's happening in this video. You've got, if you notice, there's a plug of air kind of pulling out of this acetone can, traveling this way and then being sucked up into the dog's nose. So what's happening, as the dog exhales, there is a turbulent air jet that comes out of each nostril. Just like when you and I exhale. You go like this, exhale with your nose. Those are 2 turbulent air jets. In this video, the dog is directing those air jets down and to the right of the screen. And in the world of fluid dynamics, when I pulse an air jet down and to the right of the screen, it pulls air, it entrains air in the same direction. It's called fluid entrainment. So many of you in this audience are very well aware of this. So you can see how in these images, again, the dog exhales down to the right, and by doing so, pulls odorant molecules from extended distances towards itself, then reverses flow and inhales, so sucks up the odorant molecules, analyzes it with an amazing chemical detector, I call it the hardware upstairs in the olfactory region, and repeats this at 5 times a second. So this is one of the reasons why the dog is this amazing chemical sampling system. Yes, the dog has a great detector in the hardware, but the way it samples its environment is very, very intelligent, whether it knows it or not, right? This is an active sampling system, not a passive sampling system, which is what we typically design when we develop vapor detectors. All they're doing is sucking air through a hole. They're not technically sniffing, right? To show you what that fluid entrainment looks like, take a look down here. This is just a little dust-off can, okay, like an air duster. And every time I shoot that air jet down to the right, you can see this little plug of vapor coming out. And so this is kind of mimicking what the dog is doing. Okay. Here's one more flow viz that I'll show you. Yeah, I'm pretty good on time here. All right, this is hard to picture at first, but I want you to try to get this. This is the back of the dog's nose. Imagine we're looking over the right shoulder of the dog. It's down on the ground, and on the ground, so if this is the ground here, there is a horizontal sheet of laser light right above it, and I'm filling this with theatrical fog, low-lying fog. So we're going to watch what happens the dog is, now when the dog sniffs, look at how all this material is being pulled down to him. And then stop sniffing and just inhale, like it's not real. Sniffing pulls it, inhaling doesn't do anything. Watch this when it starts sniffing. Now, see all that material? So the dog is kind of, think of it this way, the dog can reach out and grab sample from extended distances and pull it towards himself. That's what we're seeing here. So what's the point of all this? We call this biomimicry. It's this concept where we're trying to understand what nature has already figured out and try to integrate that into technology that we're trying to improve. So what we did here is take a look on the right over here. This is a commercially available vapor detector. Okay, really good for sniffing out things like TNT, explosive. We designed and printed what are essentially nostrils that plug onto this thing and pulse air. We made commercial systems sniff like a dog. That's what we did, basically. And you can see an example here. It's pushing out air to the right, and every time you see this little pulse of air coming out here. So we're mimicking what the dog does, but with an actual commercially available vapor detector. And what we found is that, don't have time to get into all the details, but the take-home message here is that by making these systems sniff like a dog, we improved their ability to detect things by about a factor of 18 on average, just by sniffing versus inhaling, just sucking air through a small hole. Okay. If you're interested in a lot of the details of this, we wrote this up in Nature Publishing years ago, and I'll have a link at the end of this if you want to take a deeper dive into all the measurement science that we put into this. But take-home message: when you sniff, compared to just inhaling, imagine the dog had infinite lung capacity. By sniffing, we get an 18x improvement. Another example of what we did is we took this dog's nose, and this is kind of creepy, but we opened up this cavern, and in here we put a little vapor collector. It's called a polyurethane foam collector. And we did the same kind of measurements where we're holding our artificial nose at a distance. We have a vapor source. And in every time when you're actively sniffing versus inhaling only, in this case we see a 10x increase in the amount of material that we're pulling. There's a lot of technical details that are under the hood of this slide here. I just don't have time to go in. But again, if you're interested, you can check out the paper later. And then a third measurement technique to make sure we weren't crazy with these kinds of results, went to visit some buddies at MIT Lincoln Labs in Boston. They have some pretty sophisticated triple quad mass specs. Hooked up the dog's nose to the mass spec, and forget about what these angles mean right now. We basically adjusted the angle of the dog's nose, but in every case, we're seeing a dramatic improvement by about a factor of 16 to 18 in the ability of a sniffing dog compared to an inhale-only dog nose, which again is what we do. So take-home message is biomimicry. Are there ways that we can model and mimic what the dog has already figured out via evolutionary processes, and integrate that into technology that we're trying to improve? Okay, so I'm at the 12-minute mark here. Okay, here's my last slide. So artificial dog's nose is more cooperative than a real dog. And again, I know there are people that have police canines and they're way more well behaved than the ones that we had. So maybe we could do this with a real dog. Maybe we should try that in the future. Jet-assisted sniffing, or this active sniffing that the dog is doing, it's better than just potential flow inhale. By doing this active sniffing, the dog is effectively increasing what we call the aerodynamic reach, the ability of the nose to reach out and grab sample and pull it towards itself. We think we can optimize and improve. This is commercially off-the-shelf systems. I think that's what that stands for. Yeah, COTS systems using this technique of biomimicry. And we're hoping that the next generation of these kinds of detectors could benefit from some kind of bio-inspired design principles that we've learned from the dog, these lessons learned from the dog. So I just want to take a minute to thank our collaborators up here. Couldn't have done this without them. If you're interested in learning more about this, you can take a look at this, screenshot this QR code here. Veritasium came out to my lab recently and did a video. If you're not familiar with him, he's kind of a popular science educator, big YouTube presence, does some great work, but he came out if you're interested in more of the flow visualization we do. Our group at NIST, you can find more information there. And then the original publication within Nature Publishing, I think it was Scientific Reports that we published this in. If you're interested in that, you can take a screen grab of this, or just, again, like Google Staymates dog's nose or NIST dog's nose. You'll find all kinds of embarrassing videos of me talking about how awesome dogs are. So with that, I am on the other side of the country right now, probably sound asleep, so I won't be here for questions. But if you do have any questions or comments, please reach out. There's my email, matthew.staymates@nist.gov. Thank you all very much for listening, and I hope, sorry again I couldn't be there in person, but I appreciate the invitation. All right, hope you have a great rest of the meeting. Thanks, everyone.
Thanks. Matt, you're not sleeping, are you?
I'm not sleeping. I'm wide awake.
Wonderful. So thank you so much. That was wonderful. And, you know, from take-home message, I can see now the ENTs here telling their patients to sniff like a dog to get the drugs in properly.
I gotta say, you know, if I was there in person right now, I would ask the audience, I'm gonna do this right now. All right, you tell me what the answer is. Raise your hand if you're a dog owner. Give me a feedback. Is it 50%, 60%?
10%.
Oh, only 10%. Okay. Raise your hand if you're a dog lover.
80%.
80, there you go. Yeah. So all you dog owners, I promise you, when you go back home, you will look at your dog differently. You'll be like, I know exactly what they're doing. I know what they're doing now. It's fascinating.
And yeah, and definitely it's not embarrassing your videos. I think you're now a famous YouTuber, almost like
you're not helping. This is more embarrassing now.
All right, I'll go to the questions. There's a few here. What is the mechanism to direct airflow in different directions during inspiration versus expiration?
Yeah, good question. So the mechanism mainly is fluid entrainment. And so many of you are familiar with this. So when you're inhaling, it's essentially a potential flow inlet, right? But when you're exhaling, you're directing high velocity air jets in one direction, which creates fluid entrainment in another direction. Yep.
Okay. And have you tested other frequencies for sniffing? Is 5 Hertz ideal?
Great question. Yes, I get this a lot. So we have, and it turns out with my understanding, so again, I'm not an expert in the biology of canines. My understanding, based on the papers that I've read, is that the 5 Hertz has to do with the amount of time it takes. It has to do with the diffusion coefficient for molecules to go through the epithelial layer. I think that's what it's called. So in other words, the dog can inhale a fresh odor scent, a fresh sample, and it takes 1/5 of a second to diffuse, and then they get a new sample after that. So when it comes to the fluid dynamics, though, forget about the diffusion coefficients. We looked at various frequencies, and it didn't seem to do much of a difference. You know, you're still, once you're kicking air in one direction, you're still pulling air in another direction, which is what we want. Yeah.
Okay, and last question. Does the inside of the 3D printed dog nose include the turbinates? And is that necessary for the dog sniffing?
Great question. Another good question. So our model did not. And the reason why is because the previous work that was done by my buddy Brent Craven, by the way, everyone should just search, you know, Brent Craven dog's nose, and you'll find these papers are fantastic. You're going to love them, because looking at all the other presentations, it's all about looking at the CFD inside of olfactory regions. But no, we weren't interested in that. What we were interested in is understanding the external aerodynamics, what's happening outside of the dog's nose. So both of these things play a key role. What's happening inside the dog's nose, really important. But we were way more interested in understanding how does the dog sample its environment around it. Because both of those things play a really key role in detection, right? Like I say this all the time to colleagues, like you can have the most sophisticated chemical detector available, right? $1 million mass spec, that's fine. But you have to bring the sample to it. And if you haven't figured that out, this very expensive mass spec is a glorified paperweight. The cool thing is the dog has figured out both. The dog has figured out, or it's evolved to have a great chemical sampling system or detector system and an amazing sampling system. So that's the take-home message there.